Wonderful. Awesome. All right. Well, thank you so much for joining us. My name is Lynn. I am a customer service rep here at Warmly Yours, and I am joined by our wonderful tech team member, Scott.
Hello, everybody. Thanks for joining us.
Thank you for being here. We're going to go over today a lot of tips and tricks for keeping roofs, driveways, and pipes safe during winter with our snow melting and our de-icing products. And if you have any questions, please don't hesitate to ask us. We'd be more than happy to answer any questions you have. If we don't get to them right away, we'll get to them by the end of today's presentation. So, kind of going over an outline today, we're going to be talking about our snow melting systems, as well as some of the applications for these systems, where they work best, and how they are kind of generally installed. We're also going to be going over our roof and gutter de-icing systems and our pipe freeze protection. So, pretty much anything that could be used to keep snow or ice from building up, we're going to be discussing it today. So obviously, nobody wants to look at this picture in August, but this is coming up really soon. And now is the time to be thinking about heating these areas that you want to be snow-free in the winter. Scott, can you kind of give us an overview of each of these products and kind of what they're used for?
Well, first of all, when it's 95 and humid, this is a refreshing photo. I don't mind seeing this at all.
Fair enough.
We've had enough of that stuff. But what we're going to do here today is we're going to talk about how to keep your pipes from freezing, how to get the melting water from your roof down to the ground, because that's really what it's there for, and also for melting the snow and not only clearing the snow, but evaporating the water so it's a dry surface. So we'll be talking about those different outdoor options and also indoor for the pipe freeze. And it's how to get through your winter without having any catastrophic problems.
Absolutely. That's what we're here for. So first, we're going to go over our snow melting systems, and these are available in cable or mats. And we can definitely help you figure out exactly which system you need if you want to reach out to us. But kind of generally speaking, Scott, can you kind of tell us what is best for what kind of pavement?
Well, you have the cable there in the spool at the bottom, and that same cable you can buy like that in a spool, or you can buy it pre-attached to a mesh product that's 2 feet wide or 3 feet wide. And what that does is it's pre-spaced on there every 3 inches. So if you're comfortable with a 3 inch spacing yielding almost 50 watts per square foot, all you have to do is just roll that product out and attach it to whatever you're going to be working with, and then covering it with asphalt or cement or that sort of thing. If you're doing asphalt, 99 times out of 100, you're going to be using the mats because they are the rolls there. Kind of, we use that word interchangeably. Because they're faster to lay down and install. You can pre-cut them, lay them on the base coat of the asphalt, and then pave over the top of them, put pavement over the top of them. So it's much faster by far. The cable, what it offers you at the bottom is it allows you to attach it to whatever you want to, like rebar in concrete, allows you to attach it, and then allows you to change the spacing. You can go 3 inch, you can go 3.5 inch, 4 inch, 4.5 inch. The wider the spacing, the less watts per square foot you have, but the more area you can melt. So if you're going to do that, certain parts of the country can get by with 4 inch spacing just fine because they're naturally warmer. Places where it's colder will want 3 inch spacing, and that you can change on the fly with the cable. So cable takes longer to install because you physically have to tie it to the rebar or whatever you're attaching it to, because you have to physically do that. It's already attached to the mesh, and the mesh has holes in it that's big enough to pour concrete through. So the mesh product is primarily the product you're going to use for faster type installs. But if you need to change the spacing, or if you have curves and that sort of thing, you're going to want to use the cable.
Awesome. That's really great information to have. So we also have a lot of different ways to control your snow melting system. We have automatic controls and manual controls. Can you kind of tell us what the difference is between the two?
The manual controls usually assume that you're going to be home to turn them on or off. Or if you have a manual Wi-Fi that you're going to manually turn it on or off by using the app on your phone. So a lot of people choose a manual timer because you set the timer and it can't stay on accidentally, because if your heating system stays on accidentally for 30 days, you're going to see a very large electric bill. That's a big installation that's on 24 hours a day for 30 days straight. You're going to have an issue with that electric bill. But that's what's so good about the manual timer, is you can only set it to a maximum time and then it'll shut off, whether you remember to do it or not. The other controls, the automatic controls, like the zone breaker multi-zone in the middle there at the top, and then the premium, advanced, economy, and value, those are all automatic controls, which means you set them up at the beginning of the year, and whenever it snows, it melts the product automatically. You don't have to, I better turn it on now, or I'm going to leave it on for this. You just set it and forget it. Now, if you are getting a new system for the first time, you may need some experimentation to know how long to set the parameters for, what works best for your area. But once you get that dialed in after the first 1 or 2 seasons, it pretty much comes on and melts everything, and you really don't even think about it. So that's what's great about these. The zone breaker in the middle there at the top actually lets you heat a bigger area than you really should be able to. Because what happens is some people only have certain amounts of power available. Let's say that they have a driveway that's 100 amps, but they only have 30 amp breaker or 40 amp breaker available. What we can do is we can split that area into 3 zones and turn on 20 amps, turn it off, 20 amps, off, 20 amps, off, and then rotate through. So 2 zones are never on at the same time, but it also lets you heat this area, then heat this area and heat that area, and it just goes through. Now, since you're heating 3 times as large area as you would be able to, there's a trade-off, right? It's a compromise. All these other controls will turn the whole system on and the whole system melts at once. The zone breaker will take a while because it's doing this. No 2 are ever on at the same time. So it could take 2 or 3 times longer to melt than the other controls. And that's why if you can do it in 2 zones, it's better than doing 3. If you can do it in 3 zones, it's better than doing it in 4, simply because you're splitting up that time less. 1, 2, 1, 2 is much better than 1, 2, 3, 4, and then start over again. And that's the way that operates, because no 2 zones can ever be on at the same time. So you're only heating 1, turning it off, heating 1 and turning it off. And you could set that period for 7 minutes or 10 minutes or whatever you want it to. But that's how the zone breaker works, and it's an automatic control. But any of the automatic controls that you see, you can manually turn them on or off too. It's not like you're stuck, I'm sorry, Dave, I can't do that. It's not like Space Odyssey 2001, where the computer says, oh no, we're going to do this. You can actually turn it on and you can turn it off. So that's what's, there's a whole bunch of different controls here, and we'll find the right one if you tell us how you want it to work.
Absolutely. So I think this is a really great example of what a heated driveway can look like. It's going to save you time on shoveling and salting. You don't have to worry about the salt damaging cars, vehicles, pets' paws, anything like that. But because these are fully embedded, as Scott had previously mentioned, they are ideal when either building a new driveway, if you're going to be redoing or expanding a current driveway. That's going to be the time that you really want to look at putting the heated system in. And Scott had kind of mentioned one way you can reduce the power consumption is with our zone breaker and kind of breaking it down into smaller sections. You also can choose between full coverage and tire track coverage. Can you kind of tell us what the difference is, Scott?
Well, tire track coverage uses a lot less coverage. Usually when you'll get a phone call from somebody interested in doing their driveway, they'll say, here's my driveway sketch. Now give me a quote for this. And once they see that, it's like it takes so much power. Then they go, well, I only have one breaker available. That's the most important thing you need to think about when you're thinking about heating your driveway or walkway or whatever it is. Do you have any space in your breaker panel? If your breaker panel is completely full, then you're not going to be able to heat the driveway unless you start getting an electrician in there and taking and combining circuits, all kinds of stuff. So you really want to see if you have any space in your breaker box first. Then what you can do is you get a quote for your driveway and go, oh, that's too many amps. So we can reduce that by less than half if you use tire tracks, and that's just to heat the tires that go the space from your driveway, from your garage door out to the road, and that lets you get in and out. What you can also do is, if you look at this picture, you can heat 12 feet out or so, 12 or 15 feet out from the garage door, because sometimes people park cars out in front of their garage in the winter too. So you can heat that part, the 12 by 14 or 12 by 20, whatever that is, that area where the cars sit, and then do tire tracks out of that. So there's a lot of different combinations you can use, but the first thing we're going to need to know is what the square footage is that you have. Then we can design it and find out how many amps you're going to need, and then figure out how to design around that.
Yep, absolutely. And we do have an option for retrofitting if you have an existing driveway. So that definitely can be an option, especially if it's an asphalt driveway, and definitely reach out if that's something that you would be interested in looking into.
Yeah, one thing about the retrofit is, if the system, if that driveway, that picture right there, if that driveway is breaking up and the asphalt's 25 years old, that's not something that's sturdy enough to hold the cable. You want, let's say you 2 years ago you put a new driveway in, a new asphalt driveway. You didn't know that you could heat it. Well, that is a pretty good base that you can come in and install the new cables on top of, and then put another coat on top of that, another layer of pavement. Whereas you wouldn't want to put a new layer of pavement on top of a driveway that's crumbling, because as the base crumbles, the top crumbles, and when it crumbles, it damages the cable, and then you're out. So that's what you're going to do. A retrofit has to be done into a suitable base, one that isn't falling apart.
Absolutely. And most of our automatic controls, like we had talked about earlier, will activate at a certain temperature. And generally, that's about 38 degrees Fahrenheit or 3 degrees Celsius. Can you kind of tell us, Scott, how long the system will run for once activated or turned on?
Runtime is different than after runtime. So runtime is the amount of time that the actual event is happening. There's active snow falling, or see what the sensors is. They have a grid on the top, and then they have a temperature sensor built into them. The grid is to see if there's any snow or rain. And then if there is, it'll look for the temperature. And if the temperature is below 38, it'll turn the system on. Both of those criteria have to be met. If it's 38 degrees, the system won't turn on, or less than 38 degrees, it won't turn on unless there's rain or snow falling on the sensor. So both conditions have to be met: actively snowing or raining, and below 38 degrees. And then when one of those conditions goes away, the temperature goes up to 39, or it stops snowing, that's the event is over. That is when the event is over. Then the system goes from active melting into after runtime, which is the amount of time it takes for it to melt and evaporate what's left behind. So someone calls up and says, I got a new control, and every time it snows, I'm left with slush on my driveway. It never completely melts it. Well, what has happened is, we'll go and ask them, well, how long is the after run period set for? And they go, for like 20 minutes. Well, that's not enough time to melt all the residual. So what the system has done is, it's melted until it stops snowing, and then it stopped. You have to let it continue on to melt and then evaporate the rest of what's left behind.
Yep, absolutely. Otherwise, you're kind of making an ice rink in your driveway. If you have a big standing driveway of water and it refreezes, that's going to be a little bit of a bad situation.
Right.
And kind of speaking of that, the snow not only melts, but it really evaporates, and that's going to keep it from refreezing. You're not going to have to worry about any kind of ice buildup or problems like that. Scott, we kind of talked on this. I think we missed the slide or forgot we had this slide we could have gotten to, but the hold on feature is what you were talking about with the after runtime, is kind of used interchangeably. And another reason this is really great, besides slush or ice, it eliminates black ice and compacted snow. So it's going to just be a lot safer as well.
Yeah, if you have somebody come and plow your driveway, what's left behind is compacted snow down in the grit of whatever your driveway is. And if they don't get it that first time and they miss it, then it just starts to build up over time. And really what you just have is compacted snow that you're driving over. This completely gets rid of the compacted snow. It gets rid of the black ice, and it gives you a nice dry surface to walk in and out of.
Definitely. So for an asphalt installation, we had kind of talked about some of the ways this can be done and some of the ways this can be retrofit. Scott, can you kind of tell us what we're looking at here?
Yeah, what you're looking at is a driveway that's had the base coat put down with an asphalt paving machine. And what we've done now is if you look at those rolls, the rolls are there for a reason because they install much faster. If we had to physically tie this cable on, the asphalt people would leave. They'll go, yeah, sorry, it's going to be, we'll come back in 2 days, right? After you're done physically, putting this cable on something to hold in place. So if you have an asphalt installed, just assume you're going to be getting the rolls because that's how you have to operate while the asphalt people are there. And they're not going to sit around and wait for you. And a lot of time, as soon as the asphalt leaves the factory, it starts cooling off unless they have a heated truck. So it starts, in the 300-degree range, and then it drops and drops and drops until finally, then it becomes too difficult to work with. So the idea is speed, and the best way to do that speed is with the rolls. So they've laid the rolls down here. But if you notice, they haven't rolled them out all the way. They only bring them out a certain amount so the dump truck can come in and dump asphalt and it can be put on by hand over the top. You never ever use an asphalt paving machine over the top of the cables. So what this dump truck does, or this dump, it comes out, dumps the asphalt, it gets spread around, and then it can be rolled over the top with a machine. But you can't use a paver to lay the pavement.
Yes, that is some really good information to have. And this is a great cross section showing exactly what you were talking about. You'll start with compacted gravel. They'll do that base coat of asphalt about 2 inches, and then you would lay out that mat and you'll put the finished asphalt down.
Yeah, and notice how this is 2 layers of asphalt. To do this job correctly, you're not going to let the asphalt contractor go, yeah, we'll just put the cable on the gravel and we'll put 3 inches over the top. That's not going to work. It gets the cable too deep. And also the cable, you don't want the cable on the sharp edges of that compacted gravel. So it's got to be between the base coat and the finished asphalt. National Electric Code says the cable has to be at least 1.5 inches below the surface. So you're going to want to do that to make sure that you comply with code. So 2 layers, that's the only way to do it.
And this is a smart plan showing the tire track coverage that we had previously mentioned. Smart plans are one of our, I think, pride and joys, I would say. It is a really, really great option that we give you where you can send in a drawing of the area you want heated, and we'll actually draw up a full layout plan. Generally, within about a business day, we can have it back to you, and it'll look something like this. So, can you kind of tell us, Scott, what we're looking at here, what all these different words and drawings mean?
I love words, and there are lots of words on here. And what the main words are that you want to kind of keep an eye out for are in the lower left-hand corner, the WarmlyYours installation plan. There'll be a number there. If you ever have a question about your job, just say, I've got an installation plan number, blah, 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 blah. We can look it right up and know exactly what you're doing. That's what's so great about these plans. Also in the plans in the center there, it'll tell you how many breakers you need. It'll tell you what kind of electrical requirements you'll have. It'll tell you how many breakers are for this, how many breakers are for that. You need GFEP breakers for outdoors, not just regular breakers, and you never want to use GFCI breakers outdoors. They need to be GFEP. And then it'll tell you the total amperage of the job in the lower right-hand corner and what products are being used are called out right there on the plan. So if you look, you can see the 1, 2, 3, and 4 in a circle. That's roll number 1, roll number 2, roll number 3, and roll number 4. And if you look to the upper left-hand part of that drawing, you'll see that what's shown is the entire driveway in that little picture up there, like a thumbnail. And then it shows the colored section there, which is the part that we're working on right now. So it kind of gives you the lay of the land and then the part we're working on. So one thing I do want you to notice is that we're 1, 2, 3, and 4. There's triangles there. Those triangles represent the beginning of the rolls, and then the squares at the end represent the end. So that's where the product ends. Notice how all the starting points are at the same place, because that's where all the electrical wires come out to go over to the junction box. So to use one junction box, you put all the starting spots right there. And that way they work away from where the power is going to go into those junction boxes. The leads are only 20 feet long, so you're not going to get them very far. All the leads are designed to do is to get you from the heated spot into the junction box, which was right where circle number 1 is.
Absolutely. So for a concrete install, again, you need to make sure that it's embedded. But with concrete, you're looking at 2 to 3 inches beneath that finished surface. And we'll actually show you another cross section again, but we'll definitely recommend using some kind of rigid metal framework to hold that heat up and to tie it to. So can you kind of walk us through what that looks like, Scott?
Well, the number one problem I see when I go out and do these installations is people forgetting to put the bricks or the top hats or the chairs, whatever you call them for the concrete workers, to get that rebar up off the bottom surface. The cables are supposed to be in the middle of the pour. That's what those bricks are. Can you point at one of those, a couple of the bricks there? There's a brick there. There's a brick over there. That's what keeps it propped up into the middle of the pour. If you get it down at the bottom of a 4-inch slab, you may not get real good results. You want it to be 2 inches in the middle of that slab, and that's going to heat it perfectly for you. That's the number one problem I see out doing installs. And if you see somebody taking a rake and grabbing onto the rebar and pulling it up in the middle of your job, those rakes are really sharp. And what they do is those rakes will hook on to the rebar. But what those rakes also do is they will puncture the electrical cable that's supposed to be heating up. Don't let them do that. If you see them going like this and pulling up like a fisherman pulling a fish, that's a really bad sign. You get the system propped up in the middle, and that way the concrete just flows right through it. Now, if you take a look, this is the pre-attached cable to the rolls there. That mesh is spaced so that if you use sub 3/4 inch aggregate, which means the pieces, the rocks inside the mix are 3/4 of an inch or less, that will allow that concrete to float or pass right through that mesh. If you don't tell them sub 3/4 inch aggregate, all the rocks will be at the top and all the water and stuff will be at the bottom. So you're effectively straining your concrete, straining the thick part at the top and the thin part at the bottom, which is what you don't want to do. So that's why you use sub 3/4 inch aggregate, pour the concrete on through there, make sure that it's propped up, and that concrete will flow right through and it'll fill right to the top, and those cables will stay right in the middle then.
Definitely. And one more thing to point out, we've kind of been just using driveways as a kind of catch-all term, but this can really be used for driveways, patios, walkways, sidewalks. We've seen people do it in concrete benches. So if you're doing something like an installation with or an application with asphalt, concrete, anything like that, even if it's not a driveway, generally we'll be able to heat it.
Yeah, and you're going to zip tie those cables or zip tie the mesh to the rebar. That's what's going to hold the whole thing in place.
Yes, and this is a great way to kind of see that from the top. Again, there's that gravel, those 2 to 3 inch concrete blocks, and then that rebar or the metal frame. And you can actually see in the picture where it's zip tied. And then again, the snow melting cable and the concrete that'll be pouring over the top and filling in that space. So this was a smart plan for full coverage. And again, you can really see it's very detailed and you'll have a really good idea of your installation game plan before ever beginning the actual install on the day of. So this is showing, again, you'd kind of mentioned the starting ends are often together. The edges or the ends of the mats are usually going to be somewhere else. And then can you kind of tell us what the J is for the J box?
Yeah, that's the J box location, which is this, it's put there so all of the leads will reach. If the J box were over to the right side, this whole drawing would be flipped because you have to start from where the J box is, because that's where the cold leads need to get from the heating mat to that junction box. Then that junction box is where the electrician sends the wire from the house or whatever the building is to that spot, and that's where they connect together. Okay, you never ever do any splices in the concrete or in the asphalt. Those splices to make the leads longer is That splice is always done in a junction box. You never ever splice under the heating or in the heated surface, because if anything ever goes wrong and you need to test the product, you can't get at the leads to do that, because you don't want a splice fail that's inside concrete. That's the last place you want it. So all those connections are done in that junction box.
Awesome. And then we also recommend, or we also say that our product is able to be installed in pavers. I think that that surprises a lot of people. I know when I've gone to trade shows, a lot of installers are very surprised that this can be done with pavers, and it definitely can. So can you kind of tell us how that works or what that looks like?
Yeah, you're simply placing this heating product kind of in the bedding of the place of the pavers are going to sit. The pavers are going to be set in sand, or they're going to be set in mortar. Mortar conducts heat better than sand does, because there's no air trapped inside a concrete. So the heat from this cable transfers to this paver better if it's mortared together, because it's a one contiguous heating slab type item. But most of the time it's put into sand under the pavers. The main thing you want to make sure is that the cable is covered by the sand an inch and a half, because you never want the pavers to rest directly on the cables, because as time comes along and your pavers start to sink, you don't want them compressing the cable. So that's where it's very, very important to use the proper layers. And we've got a cross section to send you if you have any questions about how to do it. And you're not going to use a 6-inch paver, because the heat has to be able to get to the top of the surface. The top of the surface is the area that you want clear. If you make the cable too far away from the top surface, it's never going to melt. So that's why we say 2.5-inch pavers is going to allow that heat to get up through the system, and it allows you to be at least 1.5 inches under the surface, as required by the National Electric Code. Yeah, so don't be
And
dropping
oh yeah,
pavers as you go along.
yes, that is, I've come across that, and that is always a little bit of a problem. Definitely make sure these are relatively hardy cables, but you do want to be careful with them. There's no reason to test out their hardiness.
Yeah, you're never going to drive an asphalt machine over the top of these. You're never going to drive a loader over the cables. I can remember one of my first jobs here, where somebody had put this product on cables, and then the mailman drove up the driveway, and every space that a 4,000-pound item squeezing a cable between it and rebar, it trashed the whole thing. So that's where you never ever drive over an exposed cable. But once the paver's on top, it spreads that weight, and you don't have to worry about it being damaged. But you never ever you don't want to be driving anything over those cables.
Definitely. And this was the smart plan for that paver job we just showed. Again, you can see it's going to show you exactly where to start and end the mats, and it's going to help walk you through every cut and turn and every step of that install. So one of our newer products is our snow melting attachment grid, and this is an embeddable underlayment that makes it very easy to install snow melt, especially if you're going to be doing pavers. So can you kind of tell us, Scott, what the attachment grid is used for?
Yeah, this attachment grid is strong in both directions. If you pull it this way, it has the same amount of strength as this way. They make different versions where one side is stronger than the other. So one side, if you pull it like this, it'll come apart. And if you pull it like this, it's strong. But this side is designed where both sides can be pulled. And you want to make sure that you get that type of a grid, because if you buy the other kind and you start stretching, it'll just pull apart, like a gunny sack, if you pull a gunny sack apart. So if you get this, you want to make sure that you tack it down to hold it taut, because that's what you're going to be attaching the cables to holding them in place to keep the spacing the right amount. These are constant wattage cables. If you overlap them, they will burn out. They cannot touch each other. They'll overheat and fail in that spot. You have two heaters touching each other in a constant wattage cable, which this is, they will destroy each other. And what that'll do is that'll cause a short, and that'll cause a problem. So you always, when you're doing these installations, the cables should be at least 3 inches apart. Sometimes you can make it a little wider, but you can never overlap them. If you overlap them, you will damage them and you'll be in there doing that job again. And that's what this product is for. It comes in different sizes. Roll it out, tack it down, roll out the next one, tack it down, and then you can attach your cable or your mesh to that to hold it in place.
Wonderful. And this is showing a paver job with that attachment grid. As you can see, it's really easy to use. It makes that spacing nice and even and uniform, and it tends to be a really great option.
Yeah, you have to get it tight. Otherwise it ends up like chicken wire and all the wires are kind of all bundled together. You need to make sure that you do that the right way. But if you do, it's really great. Especially, not only is it good for this, but it's also good for doing cable in stairs. So if you're doing a limestone cap on a stair, you can screw or tap con this stuff down to the concrete underlayment or the concrete that's underneath, and then you can run it gives you something to tie your cable to as you go from one one stair to the next stair. So this stuff comes in really handy for that too.
Yeah, that's great. So our roof and gutter de-icing systems are our next winter heating product that we're going to be discussing. And these are really great to help prevent any kind of costly water damage, ice dams, any kind of just roof wear and tear from water being stuck or sitting somewhere. Obviously, water likes to find its way to the ground. And if it isn't able to do that, it's going to start kind of taking everything with it. So can you kind of tell us, Scott, how these systems work or really where they're ideal?
Yeah, first of all, there's two different products that are completely different from one another, but they do the same job. Constant wattage cable is a cable that's 10 feet, 12 feet, 15 feet, whatever it is. It can never, ever be cut, and it can never, ever overlap. That's what the stuff with the plug there is. That's constant wattage. And it's less expensive. Constant wattage puts out the same wattage per linear foot all the time, whether it's 10 below in ice or if it's 90 degrees out, it'll still put out the same amount of temperature. Cut to length self-regulating cable is a cable, the only cable that we sell that can be cut to length. It's the only one. It's self-regulating. So you can cut it to whatever length you want as long as you don't get too long and it'll cause a circuit breaker to pop because you're drawing too much power. But it can overlap. It can touch each other. So if you ever see a cable, I think we have a picture of it here somewhere where the cable goes up around a valve and then on, that is never done with constant wattage. Constant wattage will burn out where it overlaps each other. So that's always done with self-regulating. See, self-regulating when it's out in the open air, like that after picture, you can actually see the cable and it's not in the snow or anything. It's not in the ice. It would be probably 5 watts per linear foot. But if it were buried in ice, like the before picture, and we turned it on, it would go up to almost 10 watts per linear foot until that ice dissipated. And then where it's coldest, it gives off more power, and where it's warmest, it gives off less. It regulates itself because of the temperature. So that's what's so great about self-regulating cable. And that's where you want to keep. The reason why it's so important to think about that is because when you see pictures and when you see different applications, you'll know after just hearing my never-ending spiel that if you see a cable overlapping itself, that's self-regulating cable. So that's a good thing to keep an eye out for.
Yes, absolutely. And if you're going to be estimating your cable length needed, can you kind of tell us what measurements we recommend getting?
Well, first and foremost, the main thing that you want to walk away from this is if you have gutters and if you have a downspout, those are the places that have to be installed, because it doesn't do you any good to put triangles on the roof if the water comes down and hits a gutter that's frozen and then it starts to back up under your shingles. You've got to get that melting snow down to the ground, and it gets to the ground through the gutters and into the downspouts. Those are the two main places you need it. That's at my house. I had to remove part of the front of my house because water had gotten in. So I had to remove the front door. I had to remove like a 6 foot wide by 20 foot high section that was just rotten because the water had gotten up and gotten behind there. And whenever it would rain, I go, why is water coming from the inside of my window in this section? Is because it had ruined the ice had backed up. The ice damming had ruined that area. So now at my house, I just have it in the gutters and in the downspouts, and that water goes right down to the ground. That's the most important thing. If you want to have the triangles, that's where we need to know the overhang. The overhang tells us how far away the roof comes out from the building, because the triangles have to cover that amount. So if your letter A is 1 foot, then the triangle is going to go 1 foot to make sure that that melts. If it's 2 feet, goes 2 feet up. So that's why we have to know the overhang. And that's the most important thing. Also, if you have a dormer, you have to measure around that dormer to make sure that it can come out of the gutter, up around the dormer, then back down. Also, that valley, if you look there in letter D, if your roof has a valley in it, you're not going to go all the way to the top of the roof. You're just going to go 2/3 of the way up there. So if it's 20 feet, you're going to go 2/3 of the way and come back. So if that's 17 feet, it's also 17 feet back. So you have to keep that in mind. It's not a 17-foot measurement, it's double that to go up and to come back. So that's why it's so important to know that we need to get the water from those spots down to the ground.
Yes, for sure. And really, I like this picture because you can see how the water does want to get down to the ground. It does form icicles as it melts and refreezes and melts and refreezes. And this is prevented with the roof and gutter de-icing system. You can actually see that water just flowing melted from the gutter. So can you kind of tell us, Scott, for a metal roof specifically like this one, can you kind of tell us how that works?
Yeah, actually, this is our office here that we put it up in. And what we've done is this installation here on the right side, you can see where the cable goes across, then the front edge, then goes up over the standing seam, goes up and over and comes back down and goes across, goes back up over the standing seam, down and around. So that's the way we have that. We all know with metal roofs that when it gets real, the sun is real active, that whole thing wants to slide down. That's why you're definitely going to want to use snow guards to keep the snow from just all of a sudden falling down, because it can take the cable with it, right? If you've got 3 feet of snow and all of a sudden it all just comes down, it's going to hit those cables and rip it off. So you want the snow guards put where they normally are. That's going to hold it in place. And then as the snow melts, that snow behind the snow guard, the water is going to come down, hit that warm spot, get into the gutter, and then get out. But the snow guards still have to hold that snow up there to keep it all from crashing down.
Yes, for sure. Definitely better to not have a giant pile of snow, not only taking out your heating, but getting hit in the head with it doesn't sound very fun either.
No, nope.
And last but not least, we have our pipe freeze protection. And this is a really, really great way to ensure that you are not going to have frozen pipes in the winter and to give you a lot of peace of mind. And Scott, I think this is the picture you had been referring to where we're crossing over around the valve. So can you kind of tell us for this, I know that there's self-regulating and constant wattage. Can you kind of tell us how that works with pipe freeze?
Yeah, with constant wattage, we'd just be running a cable along the bottom there. But we know that there's heat loss or in the area of the valve or the spigot or whatever, the hangers that come down and hold up the pipe. So when you see this picture, you know the picture here is using the cable at the bottom. It's using or is using self-regulating. The self-regulating cable can overlap itself, so you don't have to worry about that. Also, if you look at this picture, whether it's constant wattage or self-regulating, you don't see the cable spiraling over the pipe. We're going to show you here in a minute or so how that's actually installed. But the self-regulating, if you have a 37-foot run, you can cut a 37-foot run of cable. With the constant wattage, you'd have to buy a 30-footer and like a 6-footer separately. and plug them in and then run them both directions. Self-regulating is the only kind of cable you can cut to length, and overlap. So that's what we've done at the bottom. The other ones come pre-wired with the plug on them. And what they also have is they have a little disc in the splice. And that splice is that straight part there, where from the orange to the black, that part in between is a splice where the heating section is spliced onto the non-heating wire. That non-heating wire is orange. That's just carrying the power from the plug over to the heater. Well, in that is also a thermostat, which will turn on and off automatically. So if you have it plugged in, and it's under your mobile home, you don't have to worry about getting under there and unplugging it every spring, or worry about going back under there to plug it in the fall, is because that disc rests up against the cable, runs up against the pipe. And it says, okay, this pipe is cold, I'm going to turn on now. So we have more details on that. I think that the temperature is between 38 and 34. Can't remember the exact number, but once that disc feels that the pipe is at that temperature or less, it'll energize the system. When that temperature goes up, it won't. So those are your two options. That cable at the top, you can't trim it, you can't cut it. So you can't install 70 feet on a 30-foot cable, 30-foot pipe and just cut it off. You can't do that with constant wattage.
Yes, definitely. And this is kind of, I think, the picture you were talking about, Scott. This is the kind of way that we recommend, or the location of on the pipe that we recommend putting the cable, correct?
Right. Right. And you see it's running at 8 o'clock there. If you have to do a double run, you can do it down at 8 and then come back at 4. That would be okay. You don't spiral it because water, especially in drain pipes, water in a drain pipe doesn't flow along the top. So there's no need to buy all that extra cable to spiral it around. The water usually is in the bottom part of the pipe. A lot of people ask, can I use this on PEX tubing, on PEX pipe? You can use it on a tube that has water all the time in it, like the pressurized side. But on a drain, that could be dry, completely dry, and you can't use it on a drain line. So those are the only kind of things you need to watch out for. If you have any questions about that, just give us a call.
Yes, definitely. All right, so I think that is it. Do we have any questions? I'm not sure. I'm going to check here. Don't see any questions here. I know Olivia will be checking Facebook. Awesome. All right, so it looks like we are all good on questions. If anything pops up while we do a little bit of housekeeping, feel free to pop on in. Our next webinar is going to be on Thursday, September 12th, and this is going to again be at 1 o'clock Central Time. It's going to be how electricians and flooring professionals collaborate on floor heating projects. So we're going to be talking a lot about working as a trade pro in this business. All right. And I see Mary, I think Mary raised her hand. So if you want to talk, you should be able to now. Or if you'd rather type it in the chat, you are welcome to as well. All right. I will let her figure that out or think on that, and then we can get back to the
Mary,
question.
you can type it into the Q&A or the
Yeah.
webinar chat, either one.
All right. And we do offer daily trainings right here on Zoom. So feel free to join us for those every weeknight. Now, Olivia's helping with the chat. Awesome. All right, and our monthly promotion for August is, of course, our snow melting systems. The cables and the mats are 15% off, so be sure to visit our website for more information on that. We do recommend rather that you be installing these systems right about now. You want to get that on the books with whoever's going to be doing the installation so that it can be done by early fall. So definitely be sure to check that out and take advantage of that promotion.
Well, Mary asked,
Mary asks,
yeah. How
go
does
ahead.
how does the non-regulated being controlled? It's that the plug-in one we talked about has that a thermistor in it, or a thermostat that turns on when it goes below a certain temperature, and it just plugs into an outlet, a GFCI outlet. So you can just plug that in an outlet, and the self-regulated is turned on using one of our controls. It can be done automatically with one of our controls that we showed in one of the earlier screens that you can take a look at. And whenever it snows, we also have gutter sensors. So when the gutters get wet and there's snow in there, the system will turn it on automatically and run it until that gutter is dry. So that's what those are usually 9 times out of 10 done electronically. The one I have uses a control that's got the gutter sensor, and when that gutter sensor is wet and covered, it'll turn it on, and when that gutter sensor dries out, it stops. It does it all automatically, because you don't want to be, because that's up on your roof. You don't want to be up there climbing around. Oh, I need to unplug it now and plug it back in. You don't want to do that. You want to use that automatic control. So hopefully that
What
answers.
about for with pipes? Is there a difference between self-regulated controls for pipes or roofing?
Yeah, for pipes, those are usually for like industrial jobs, when they need to melt or keep the temperature of the pipe at a certain temperature. We have a pipe control that will keep it at a certain temperature, that regulates it. It's got a sensor that sits right against the pipe, and then it's an automatic control that, oh, it's getting below that, so it'll turn it on. So yeah, that's done automatically with a pipe freeze controller, which are on our bottom of the cable. At the bottom right is self-regulating, is the
Yes.
self-regulating cable. Because you can, so if you look really, really close, you can see it's got two bus wires inside with this mystery goop in between them. The mystery goop changes its connectivity depending on the temperature. So the colder it is, the more it connects and makes it higher wattage output. When it warms up, those molecules get further apart. It doesn't conduct the electricity as well, and it cools off. It looks similar to Romex cable, but Romex cable just does not have the matrix inside that changes the watts per linear foot density. So yes, it does look similar to that. But a Romex cable will have an individual ground, as usually 3 wires inside. If it's 12, 2 and ground, it'll look like that. Then there's a ground wire. This has a ground sheath that goes around the whole thing. So that's the main difference between it, is the sheath that goes around it, and the matrix that regulates the temperature, regulates the watts per linear foot. It's the mystery goop, I like to call it.
Yeah, that's not a bad term for it.
So
All
very,
right. So we
very good
talked about
questions, Mary.
yes, definitely. Thank you for helping out and asking those questions. We talked about daily trainings, talked about monthly promotions. All right. And last but not least, we are going to email you after this. We'd love to hear about any your experience, just kind of in general on the webinar, any comments, suggestions, compliments, especially. I think Scott and I will take. So anything you'd like to tell us about with today's webinar, let us know, especially if you have an idea for a future webinar topic. Let us know. We are always looking for new topics that people are interested in watching. And you can always reach out. Scott has mentioned it a few times today. If there's any kinds of questions, or you just want to chat about your specific project, call us, email us, visit our website. We have lots of information on there. Definitely reach out if we can be of any assistance. And I think that is all we have for today. So thank you everybody for joining us. Thank you, Scott, for being here. And until next time, stay warm
And be radiant. Thanks, everybody.